I think there's. Can you take up the live presentation from me, sir? Have you done that? Can you see it clearly? Okay. Okay. Everything has been written. Listen. we are going to go deeper in the discussion on tensors, okay? And the framework we're using will be PyTorch, okay? Good. Remember last week, we said PyTorch is an open source machine learning and deep learning framework. We've talked about that, okay? We said it was initially used by Facebook, okay, before it became available for everybody. One of the reasons is because, well, a lot of scientists, a lot of people use it, okay? So that means we can get support. If we run into problems, maybe with our code or anything, the likelihood that somebody must have seen that same problem and solved it is very high, okay? So if you just do a simple Google search, you can easily find solutions to some of the problems that you might have or you come across, okay? So these are the topics we are essentially going to cover today, okay? We are going to reintroduce the concept of tensors. Remember we said tensors are multidimensional arrays, okay? We are going to see how we can create a tensor in Python using the PyTorch framework, okay? We are going to see how we can get more information about tensors, okay? Like the dimension of a tensor, you know, and the likes. We are going to now see how we can manipulate the tensors, okay? We're going to see how to deal with the shapes of tensors, indexing of tensors, which is very, very important. And then in your previous machine learning class, you talked about, I'm sure you were introduced to the NumPy array, okay? Which is another, we can think of it as a linear algebra package for dealing with also array, okay? We're going to see the similarity between these two. And we're going to talk about reproducibility. And lastly, how to run tensors on the GPU, okay? As opposed to CPU. All right, so let's get started. Before I continue, this notebook was actually adapted from this GitHub repository. So you can go there and get more materials, okay? You just follow the link and you have more materials that will cover a lot more concept, even beyond this class. Okay. Now, I want to assume that everybody here is familiar with the Jupyter notebook, okay, and the Jupyter environment. Okay, if you're not, just know that in a typical Jupyter environment, you have these things called cells, okay? And a cell can either contain Python code, okay, markdown, okay, or raw data, okay? So the code that I'm going to be writing will be in these cells. In fact, the entire notebook is created that way, okay? There are some cells that are marked down, okay? And there are some cells that contain code, which is what you see in this example, okay? And then there are some cells that contain raw data, all right? One very important thing you also need to understand here is that each cell comes with, think of this as execution. In programming, codes are executed line after line, isn't it? Okay, so if you see cell, it gives it a number telling me the order with which the cell has been executed. Okay, all right. I say this because you cannot. If I run this, for example, now I get this number here, indicating that. Okay, so let me give you a typical scenario. Let's say I don't execute this, and I come maybe down here to execute this. It essentially imports all the libraries that I need. Are you following? Okay. In programming, you have to import the library before you use it, isn't it? But the next cell here uses the library. Okay. It doesn't have any record, okay, of the library being imported, which is why what you see here, okay, I mean, you're most likely going to be seeing this kind of error. It says torch is not defined. I'm using torch here. Okay, I have not imported it. Is this clear? Okay, and if you rightly say, you can see that it made this one number 1. Okay, are you following? So what I needed to do would have been to execute this first before the next one, and I can see correct that. If I come back here and execute this, okay, this imports the torch library. Oh goodness. Okay, I need to fix something quickly. Just give me a moment. Okay. So in my version of Colab, in my version of my Jupyter notebook, there is some error. Okay, I got while installing the Torch, and I've not fixed that. So, well, let me just move to Google Colab instead, so that I don't waste too much time. Okay. All right, so this is exactly the same thing. Okay. I'm just going to make a new notebook. Okay. All right, so while that is loading, the internet is a bit slow. So while that is loading, let's go back to the notes. So what do these things mean? Okay, this essentially just imports the library. Okay, remember the PyTorch. The first line imports the library, okay? And the second line is just to check the version of PyTorch that I have installed, okay? All right? So these versions may differ depending on the library, the version of the library you have installed, okay? So like I said, import torch is the first line. Oh, okay. All right. Okay. Now on the next line, I can check for the version. Okay. Most times what people do is once you import the set of libraries, you just run the cell. Okay. All right. Now the reason why I want to do this is because I want to have some kind of intelligence, okay, while I code. So, okay, so it's running at the moment. It's going to give you the particular number, okay, which is the order of execution of that cell. Okay, this is the first cell. All right, so this is 1. Right? Now, because I have imported using the torch library itself, so I can do torch dots, okay? If you do a tab, yeah, space and comma, and control and space, you should get some kind of intelligence, okay? In this case, what I care about is version, okay? So that would be version. Okay. All right. So let's see the version that comes with my Colab. Okay. So it says that I have Torch version 2.3.0. Okay. All right. With CUDA version 1.2.1. Okay. So I've just imported Torch. All right. I can start playing with creating tensors and doing stuff and the likes. Okay. So that's the first part. Remember, like I said, a tensor is just some way of representing data. Okay, it's a multi-dimensional array. Okay, if you want to represent the picture, okay, on your computer, that would be some dimension, some width and some breadth. Okay, if you take a picture using a camera, for example, everything is stored as numbers. Yes, that thing that is stored as number is an array. Okay, the individual value of that array represents the pixel intensity of the image. Okay, so like in this case, all right, it has 224 pixels on the vertical axis, and well, the dimension is 224 by 224. Okay, but this is a colored image. Okay, so we can split the image into a band of red, a band of blue. Okay. Okay, you can split it into 4 bands. Okay, that's cyan, magenta, something, and black. Okay, each band is going to be of dimension of the same size. In this case, now it's split into 3 bands, 3 colored bands. This first band captures this all the intensity. Okay. All right. The second band captures this kind of color distribution, and then the third band captures this kind of color distribution. So in general, this will give me a tensor, okay, of how many? There are 3 of these. Are you following? Now, each of them is of size 224 by 224, and that is going to be represented by these numbers here. Okay? So this is important because when we do practical applications, okay, and you take a picture from maybe your webcam, all right, okay, and then you extract the picture intensity. Yeah, either going to, if it's black and white, okay, then you don't need these 3 bands. It's just either the pixel is that very dark or very white. Okay, so this will collapse into just 1 band. Okay, but since this is a colored image, all right, and the kind of representation is I think the CMG. What's this color band now? The 3 color band. Anyway, you can look it up. So in this case, we represent the 3 colors, the image as 3 color bands. Okay, 3 primary colors. Okay, the first one, the second one, and the third one, but each of them have the same intensity. Okay, so together you get an array of numbers. Okay, where the number indicates the pixel intensity based on that band. Okay, so if this, for example, captures yellow images, okay, all right, each pixel can either be between 0 and 1, which gives you the intensity of yellow, okay, or it can either be 0 or 255, which also gives the intensity of yellow. Any questions on that? Is this clear? Okay, so in general, everything is just a tensor, and we can represent the whole thing with just a simple array of numbers. Okay. A scalar value that is not an array, just a single value. Okay, or these multi-dimensional arrays. So what you see here is a tensor whose value is 7. Okay, So it's like I'm saying I have a variable. The name of that variable is scalar, but the type of the variable is a tensor. Are you following? Okay. And then the value of that tensor is 7. Okay. So let's look at it. Okay. All right. So I can say scalar touch dots tensor. Like I said, if you want to see the IntelliSense in Google Colab, press the control key and space. Okay. So it should bring down this suggestion. So what I want is to send a tensor. The value should be 7. You can put anything you like there. Okay. It's like declaring that a variable scalar is equal to 7. Okay, but this time it's not just any kind of object tensor. Okay, that's how you create a tensor, a scalar value that is a tensor. Any questions about this? Any questions? Okay. Now the cool thing is it's a tensor. I can just print this value. Okay, I can add it. Okay, with another value. Okay, so here I'm printing the value of, I can just do simple arithmetic operation on the tensor. Okay, are you all following? Seven, but in the next page I added 10 to the tensor, so giving me 17. Is this clear? Okay. Now, every tensor has a dimension. Okay. The dimension of the tensor, okay, will give you
can you scroll the bit of
this one? Or this one? Okay, I should increase, okay, like this.
Scroll it up.
Like this? Okay, is it this one?
Yes.
Okay. All right. So that's that. Okay. Did that? This is a scalar value. It's not an array. Okay. All right. Scalar values tensor have a dimension. Okay. Are you following? All right. This is 7. There are no open square brackets. It's not an array. Okay. This is now a dimension 1 tensor. Okay. Let's see. I can do scalar dot dim ndim. I think it's ndim. Yep. Okay. Ndim meaning number of dimensions. Are you following? It's 0. Let me start all over again. I think we have lost connection. So let's start. So I run this. Okay. So we have, this is of dimension 0. Are you following? What if I now make another tensor? Let's call it scalar 2. Okay? All right? But this time, it is not a scalar value, but it is inside a square bracket. Okay? If you see it as an array tensor. So let's call it scalar 2. Okay? I make touch the tensor. Now I put it in bracket and I put 7. Okay? Are you following? All right? I run this, even though it is still 7, okay? But this 7 is in brackets. So let's see the dimension of this. Okay? You can see it's 1. Okay? So you can think of the dimension of the tensor as a number of open square brackets. Very important. Okay? Now, a scalar value is just as the name implies. Okay? In physics, they'll say you can either have a scalar or a vector. Okay? It's essentially the same thing we're doing here. Okay? Now, in PyTorch, a tensor can either be a scalar, okay, or an array. Okay? Are you following? So we think of the dimension of a tensor as the number of open square brackets. Okay? So if you go back to this tensor, there are no open square brackets here. It's just 7. Are you following? Okay? Which is why the dimension is 0. None. Okay? In this case, it is still the same information. Okay? But packaged in a different way. All right? Still the same information, but now I have put it in brackets. How many open square brackets do I have here? 1. Okay? If I check the dimension of this tensor, okay, it's 1. But they both carry the same information. As a matter of fact, they are both carrying 7. Okay? It's just that one, okay, is a one-dimensional array. Okay? The other one is a scalar. Any questions about this? Okay? Now, if you notice, while we were printing the value of this tensor, it's giving me the complete description. It's telling me it's tensor, open bracket 7. Okay? If I want to see the actual item, okay, in that tensor, all right, I will call the tensor object, and I'll reference the tensor object dot item. In this case, if I do scalar dot item, it's a function. Okay, what I get is the item stored in that tensor. In this case, it is 7. Okay. Now let me ask this question: if I also do scalar, which is scalar 2, okay, dot item, what do you expect to find? Or square bracket 7? Let's find out. Because I don't know. It's 7. Okay? The content itself is what we're interested in this case. Okay? Is this clear? Now, because these are tensors, yeah. Oh, yes. Open square brackets in Python signifies a list. Okay? We can also treat it as an array. All right? So this, so what you see here is that you're making a tensor, okay? That's also a list, okay? And the content in it is 7. All right? So you can think, in this context, we can think of the list as an array, okay? That has only one element, and that element is. The point I'm trying to make here is this. I'm trying to describe how you can put a meaning to the dimension of a tensor. That's the focal point, not whether it is a list or an array. Okay? And this is important when you're trying to look at the shape of these tensors and manipulate them as well. Okay? So an easier way to look at this is to say, okay, well, how many number of open square brackets do I have within that tensor definition? Okay? If it's 1, it means the dimension of that tensor is 1. Okay? If there are 2, it means the dimension of that tensor is 2. That's the focal point. Okay? That's person's question. Okay? As a matter of fact, we can even go further. Okay? I can make tensor. So I think I should have called it, instead of scalar 2, maybe an array or something. Just confuse some people who already know such distance. So let's make another tensor. Let's call it B. Okay? All right? This is a tensor. Okay? There are 2 square brackets inside. Yes? Okay? In the first square bracket, let's say I have 2. Okay? Let's just leave it like this. Okay? My point is, the number of dimension of B will be what now? Okay? So B dot n dim should be 2. Okay? This will help you easily understand tensor shapes and how to yeah.
When I tried to run it, it says Scalar is not defined.
So this is my definition of Scalar. You have this run. If you don't, if it's saying Scalar is not defined, maybe you have not run the cell. Okay? So it doesn't see it. Okay? Is this clear? That's the point I'm trying to make. Okay? All right. That's scalar. Okay? A vector, think of it as a list of numbers. Okay? Maybe that also will put some light to what the online user is trying to say. Okay? Not a single value. And in that list, there could only be one item. Okay, like in the case of this one. Okay, this is actually a vector, not a scalar. Okay, it's a list. Okay, with one item inside. Are you following? Okay. We can make a vector, okay, which is a list of items, okay? Essentially, we just put the brackets, okay, and then we put the number of items we want in that bracket, okay? So in this case, let's say a vector torch.tensor, same command, the same way of initializing tensors. In this case, I will now make a list of items, okay, or an array of items, depending on nomenclature, okay. But in PyTorch, this is actually a list, okay. Even though we can, anyway, let's not go that deep. Okay. So now I can put anything I like, 7, 8, 9, okay. All right. This is now a list of numbers, okay, but together it's a tensor. Are you following? What is the number of dimensions? 1. Okay? Now, do not mistake the number of dimensions with the shape of the tensor. Okay? There are 2 different kettle of fish. Okay? Like I said, the number of dimensions, think of it as the number of open square brackets. Okay? All right? The shape of that dimension will then be the number of items in each dim. Does that make sense? Okay? Like in this case, the number of dimensions here is 1. Okay? How many elements are in the first dimension? That's one dimension. 3. That's the shape. You see the difference? Okay? Which is why we need to motivate the idea of the number of dimensions. Okay? And then we can move on to the shape of the tensor. All right, so for this vector, the number of dimension is 1. Okay? Good. But the shape, like I said, gives you the number of elements per dimension. Are you following? In this case, I can do vector.shape. It will tell me that in the first dimension, okay, how many items do I have there? 3. Okay, I'm not strictly following the note. I'm just changing it so that you see, you get a good. Does this make sense? All right. So it means in the first dimension, there are 3 items there. Okay, the first and the only dimension in this case. Are you following? Okay, let's do another example. Let's call it vector 2. Okay. Now I have how many dimensions in this case? Okay. How many dimensions do I have? How many dimensions? 2, right? How many items in the first dimension? Are you sure? No. Look at it again. 2 items in the first dimension. In the second dimension, how many items? 3. Do you get the idea? Do you get the idea? Good. We are getting somewhere. If you ask questions, it means you're paying attention. All right. The first dimension is 2 because this is the first bracket. Okay? All right. How many items are in this first bracket? Just count this one as one item. Okay? Count this one as another item. How many? 2. Okay? The second dimension is this. Yes? How many items are in the second dimension? 3. Okay? So why this vector has 2 dimensions, the shape is going to be 2 by 3. Does that make sense? Okay? So let's see. Vector 2 dot shape. Two by 3. Okay? 2 items in the first dimension, 3 items in the second dimension. Is this clear? Yes. Yes. I understand. But okay? So that when we now start talking about a tensor of 100 dimension, how are you going to write it as a matrix? Okay? All right? I understand your point because this is actually a matrix. Okay? All right? But if we have 3 dimensions, you have a cuboid, a cube, right? What about 4 dimensions? Okay? What about 5 dimensions? Then it becomes very difficult for you to visualize. So let's just stick to this representation so that it will be easier for us to manipulate. Does that make sense? Okay? So like you rightly said, what you just saw is not actually a vector, but a matrix. Okay? because a matrix has how many dimensions? 2. Okay? And that is exactly what you see here. Okay? So let's go back to the Colab and make a matrix. This is actually a matrix, not a vector. Okay? Bad naming notation, but I mean, we are learning. Okay? So let's make a matrix. Okay? That is also a tensor. All right? Let's make a matrix with dimension 4 by 9. Okay, 4 by 5. Okay? So it means how many open brackets are we going to have? No. 2, because the matrix is a 2-dimensional tensor. Okay? So this is the first dimension. Okay? We want to make 4 by 5 items. Let's just put anything we like there. Okay. So we now have a matrix of shape what? 4. Is it 5? This is actually 4 by 4. So this is now 4 by 5. Okay? Are you following? Number of dimension 2. Okay? The shape 4 by 5. Any questions? Okay? You see how it's getting more and more complex. If you want to visualize it, this is actually a cube. Okay? All right? What is the shape of the dimensions? Huh? In the first dimension, how many objects do we have? 1. Three. So what is the shape of this tensor? 1 by 3 by 3. Is this clear? That's the number of dimensions. In this case, there are 3. Okay? And the shape is 1 by 3 by 3. Okay. So what I'm saying is the dimension, the number of dimension, okay, in a tensor is actually the number of open brackets, square brackets. Okay? All right? So if you look at this matrix, okay, how many first open brackets do we have? Square. Two. So that tells you the dimension of that tensor. Okay? The shape of the tensor is the number of elements in each dimension. Okay? All right? In this case, the first dimension is this defined by this square bracket, right? How many of elements? Just imagine that these ones are just variables. Okay? Okay, how many elements are inside the first dimension? This one is 1. All of them, everything separated by a comma. Okay? This is 2. This is 3. This is 4. That tells you in the first dimension, you have 4 items. Okay? All right? The second dimension, which is defined by this open square brackets. Okay? How many elements do we have inside? Okay? 1, 2, 3, 4, 5. Okay? This means that the shape of this tensor is 4 by 5. Okay? All right? So we took it a bit further to say, okay, if we have this, how many dimensions do we have? 3. 1, 2, and 3. In the first dimension, you only, in fact, look at the cool thing about Colab is it even colors the square brackets to give you an idea. Okay? If you look at this, the items in the first dimension, they are defined by the brackets with, what color is that? I am bad with colors. Is it brown? Yeah. They are defined by how many of those brown brackets you have within that area. It's just 1. Okay? The second dimension, all right? How many items do you have in the second dimension? Defined by those blue brackets. 3. Okay? Now, in the third dimension, how many items? You don't even have brackets. You have actual scalar values now. How many of them? 3. So this tells you that the shape of this tensor is 1 by 3 by 3. Is this clear? Okay? Let me modify this a bit. Okay? Now I'm going to do something. What's the shape of this tensor? Oh, how many dimensions? 3. Now, what is the shape? Are you sure? Let's do it this way. There are how many dimensions? Hold on, calm down. There are how many dimensions? 3. Let's start with the first dimension. How many items do you have there? 2 items. Okay? In the second dimension, how many items do you have? Okay? In the third dimension, how many items do you have? So what is the shape of this? You're still saying 1. 2 by 3 by 3. Okay? And then the dimension is It's 3. Is this clear? Okay? All right? If you get used to this notation, you wouldn't worry about whether a thing looks like a matrix or whether it looks like a cube. Okay? You'll just be thinking in terms of dimension. Okay? Are you following? All right? And one more thing, since this shape is an array, okay? All right? you can think of the location of these things as axes. Okay, this is axis 0. Okay, that's the first dimension. This is axis 1. That's the second dimension. This is axis 2. Okay, that's the third dimension. Any questions? Now, if you have all this, tensor understanding and the likes, you can start even working with some complex structures. You can just, load data from Excel file. Okay, all right, and then, if you load a spreadsheet, for example, how many dimensions is the spreadsheet? General spreadsheet. What's the dimension? That's 2 now, isn't it? Like a matrix. Okay, it's a particular sheet. All right. So if you have within a worksheet, maybe you have 5 sheets. Okay, and each sheet is a matrix. So that gives you how many? That was the total shape. 5 by the number of the dimension of each sheet. It's as simple as that. Okay. So this, all what I've just said is captured here. Okay. All right. How many dimensions do you have here? 3, right? Okay. All right. The shape of this tensor, or the size of the tensor, is 1 by 3 by 3. We've seen it. Okay. Now, the dimension or the axis in some cases, okay, is defined by the order of the open square bracket. So for this one, this is dimension 0. Okay, if you start counting from 0, not 1. Okay, this second one is the dimension 1. Okay, this is the dimension 2. Okay, all right. The total number of elements in dimension 0 is 1. The total number of elements in dimension 1 is 3. The total number of elements in dimension 2 is 3. Okay, is this clear? Remember last week or the week before, I said that we saw that most of these deep learning things that we're talking about, they are essentially matrix multiplication. That's what happens under the hood. Okay, so let's try to understand how we can multiply matrices, multiply vectors, and the cool part, like I said, multiply matrices and vectors in very high dimension. Okay. We, in this class, know how to multiply maybe 2 by 2 matrix. Oh, well, a 2-dimensional matrix. Okay. What if you are given a 5-dimensional or a 20-dimensional matrix to multiply with another maybe 20-dimensional matrix? Okay. And square matrix. How would you do that? Of course, you can't do that in your head. Okay. You may not even be able to do that in a paper, but we can write a simple code to do that. Okay. But before we start doing stuff like that, we need to understand how these dimensions change once you multiply 2 matrices together or 2 vectors together. Okay? That will give us a sense of what to do when we start running into trouble, especially with debugging the code. So let's start by simple scalar multiplication of a vector. Okay? So if you have a vector, you multiply it with a scalar value. What does it mean? Okay. All right. So scalar multiplication of vectors essentially just multiply all the elements, multiply the values element-wise. So this is what I mean by that. So let's make a vector. Okay, so I have a vector V. All right, it's a 1-dimensional 1D tensor. Okay, it has 1 dimension. All right, and the shape of this is what? 3. Okay, all right, in the 0th dimension. I can simply multiply this with another value, which is a scalar. So let's call it V1 is equal to V times 2. What do you think will happen? This one. Okay. That's a jagged. Okay. All right. So somebody asked a question. Let's say that's a very good question. So let's say we have a tensor. The tensor. Okay. All right. So this is a 2D tensor. But the value of the last dimension do not match. Let's just make items in the first dimension. Okay, so let's say we have that. Oh, what am I saying? Sorry, just this. Good. This is a 2D tensor. First, look at the second dimension. The first value, okay, but the second value just has one item. What is called a jagged matrix. The dimensions, dimension shapes. In this case, you pick dimension as the shape. It's still a 2 by 2. Irrespective of the fact that this only has one item here. Are you following? So you're saying the highest number of elements in each dimension is the shape. T. So let me call this T. So I don't. Okay. It's dimension, but in the same dimension, there is one item. NumPy supports a jagged. Okay. So if I was to do this in NumPy, but it is assumed that the matrix or the array in the case of NumPy. Let's say I put 2 comma that. Okay, this might be as none. That's no item. None. Nothing exists there. Let's see. They don't accept it. Okay. Let's see. I put none there. So. You cannot infer the type. So they have to an array definition. Okay, so it's not going to accept it. Touch, you don't accept with this touch. So I don't know if that answers that question. The largest, each dimension. That will give you the shape. Okay. So let's our discussion. So we have a vector. we want to multiply it with a scalar. In this times 2. So my question is, what will be the final output? So I'm multiplying a vector. What will I get at the end? So vector multiplied by a scalar, vector is to the initial vector. This is going to be 4. That's one operation. Another operation is the dot product. The dot product between two tensors. Two vectors gives you a scalar value. Okay, we can do the same thing here. And that is, okay. So if I have two vectors, okay, I can take the, depends, okay. I like to visualize definition of vectors, a column vector, okay, in this form. Depends on how, so this is the matrix, okay, and I think we've seen it already. Okay, of this number of dimensions, 2, obviously, in the matrix. Okay, dimension is this. Is it? How do you represent it? How many items in the first dimension? How many items in the first dimension? Huh? How many? 1. Huh? There has to be one answer. I mean, there's 6. This bracket, how many items? 6. Okay. The second dimension, items you have there? 2. So if you code this as it is right now, 6 by 2. Is this clear? Okay. In the course of writing your code and all that, you might just want to random matrix. Okay. It's very easy to do in Tensor. A random matrix. Okay, or a random tensor, where you specify the size. So let's try it. So okay, where you specify the size or the shape of the tensor. Let's say this is 3 by. All right. So this gives me a random. Okay. What's the dimension of this tensor that I just created? How many dimensions? 2 dimensions. Okay. By 7. Okay. 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 This is where I can make a crazy random Can you visualize this tensor? Two. How many dimensions? Why is it two? Oh, no. 3 items there, or 0 dimension, 1 dimension, 2 dimension, 6, 7, 8, 9, 10, 11. Okay, but the shape is the 0 dimension, 7 items in this in the second dimension, 2 items in the fourth dimension. That's why I want this. This is actually a very large matrix. Okay? It's 3 times 7 times 10 times 2 times 4 times 2 times 3 times 3 times 2 times 2 in this matrix. So it's actually a very large tensor. Okay? So you'd expect this, because it's really large. Maybe I shouldn't have done this. Move on while we're waiting. Yeah? Oh, okay. All right, so you can also make tensors that are all zeros. Okay, the entries in the tensors will be all zeros. Okay. All right, you can also make tensors that are all ones. Okay. Okay. And very important. Okay. Tensor that is maybe yeah, 5 by 5 of 25, right? 5 by 5 to a different shape, maybe by 3. Sorry, 5 by 5. 5 by 5 is used in 5 elements, yes? A different shape, maybe 25 by 1. The total number of elements must match. We have a problem. Continue. We have just how many minutes? All right. So I think in this case, you might want to arrange numbers to 100. Okay. Numbers in serial order. You use the just like the range function in Python. Okay. the end value and the step. Okay. Generated will always be the difference between the value generated will be one step the actual end value. Okay. 1 to 10. Okay. I'll put 1 here as my start value. So that I get 1, 2, 3, 4. I want it such that there is a step in this case. So one implementation, this function has been okay. This mean it simply means that they are the of that function in subsequent release. Okay. Higher version of Torch, there's a likelihood that okay. All right. Is this instead arrange, not range? Where you specify the stats, okay. So in this case, if you execute this, you get values 0 all the way to 10 minus. Okay. Tensor, like another tensor. Okay. It means you want to create your tensor that you're passing. Okay. Like in this case, I want to some other tensor. All right. What does this other tensor is? Size 10. Okay. So it means that this new size, but the content will be 0. Okay. And that's what we have. Now, there are different data types. Okay. There are many data types. Some are specific to CPU in GPU. I think I've explained what the difference. So getting to know which is which can take touch.CUDA anywhere. The tensor is being used in a GPU. Okay. Are generally float. Okay. 32-bit. Touch.float. Okay. So there are reasons for this. Okay. Okay. Now you can create a tensor of a specific. We're using this function plainly without any other parameters. Okay. A particular type. In this case, by default, this is going to be a floating tensor because the values. Okay. If D type to be null, this will default to floating. Okay. I can specify that this tensor should be used in the CPU. Okay. And one very important thing which we are going to look at while we are is this very parameter require. Set this to true, it means that whatever operation that is performed on this tensor will be tracked. What that means is you can now calculate the gradient of that operation based on. Okay. All right. So by defaulted to false, I guess. let's even see if I still have network. Okay. Let me just respect myself and do. Okay. Because we're almost out of time. Okay. Now, it also failed. I think the very good. Let's see. Okay. So apart from, you can also check the data type, okay, for that tensor, lives in, okay? This tensor that I just created. Okay, this is random. Okay, so as you can see, we've talked about this, so let's not overflow it. Random tensor. I can check the data type. Okay. Leave. Okay. Whether it is in the CPU or in the GPU. Device. So in the CPU or the GPU. So this tensor. All right. This is important. It means that if I'm going to do on this tensor, the operation will be performed on the CPU. Okay. Okay. I would have to move this tensor to the GPU. Models. You have some, in most cases, when we start doing, you see it. You have to move them to the GPU so that they can. From the shape, the type, and the device, and all that. About yes, we can continue. Is it time? I'll allow you guys to go through this. Okay. We'll continue from there. Okay. So, any questions? Go through the note. I think it's very explicit. But I think you will share it. Yeah. So please go through the notes. If you can let me know.
I follow the steps in the note.
Okay. So any questions? Again, why not? Yes. You can do it on your local machine. If you have a browser, you can run it. Okay. I should do it in VS Code. There's a plugin. There's an app. Okay, that comes in this. You can do it in VS Code, but yeah, you need a plugin for that. Just install an Anaconda or Miniconda. Working on the browser. Any other question? So, brings us to the end of the